Hello students, this is lecture number 2 of chapter electricity. In my previous lecture we discussed about the basics of charges, the definition and the two very important properties of charges, that is charge is having interacts with the electrostatic force, that is like charges repel each other and like charges attract each other, and second was the quantization of charge, in which we discussed that any free charge can be expressed as the integral multiple of the basic unit of charge, that is charge of electron. In this class we will discuss about the third important property of charge, that is conservation of charge, which says charge can neither be created nor be destroyed, but it can only be transferred from one body to the other body. One more modified statement is there. The magnitude of charge at rest will be same as the magnitude of charge in motion. When we say this statement about the rest and motion, we always relate this with the conservation of mass. Now if you are able to see this formula which relates the mass of an object with the velocity, if it is moving with velocity v, m is equals to m naught upon under root of 1 minus v square upon c square. This formula relates mass of any object if it is moving with velocity v. Here m is the mass of the object moving with velocity v, m naught is the rest mass. Rest mass means when a body or an object is at rest, then the mass of that particular object or a body is termed as rest mass. V is the velocity with which that particular body is moving, and c we consider the speed of light. This is the symbol for speed of light. Now if this body is moving comparable to the speed of light, that is when we put v is equals to c, the velocity of this object is considered to be same as the velocity of the light or the speed of light. If v becomes equals to c, this term will becomes 1 square upon 1 square, that is 1, so 1 minus 1 will be 0, and anything divided by 0 is undefined, that is infinity. And from this expression also it is clear that if v increases, the mass also increases. That means the value of mass at rest will be different with the value of mass if it is moving with a certain velocity. Whereas in case of charge, the magnitude of charge at rest will be same as the magnitude of charge in motion. Suppose if we take an example that at rest the magnitude of charge is 5 coulomb, so in motion also it will remain 5 coulomb, whereas in this case, in case of mass, the mass changes with velocity. So we can say that charge is conserved but mass is not conserved. Here I have written this note also. The charge is conserved, electric charge is conserved, but mass is not conserved. The fourth property we will discuss as the additivity of charges. Let us consider this is an isolated system in which 4 point charges are residing, Q1, Q2, Q3 and Q4. So the net charge of this isolated system, the total charge of this isolated system can be obtained as the algebraic sum of the magnitude of all the charges. Suppose Q1 and Q2 are having a magnitude of 2 coulomb and 2 coulomb each, and Q3 and Q4 are having a magnitude of 1 coulomb and 1 coulomb each. So the total charge will be equals to 2 plus 2 4 coulomb plus 1 5 coulomb plus 1 6 coulomb. So the total charge of the system will become 6 coulomb. This is just an example. This elaborative expression can also be written as like this. The Q net will be equals to, this is the summation sign, sigma I is equals to 1 to n, where it is written Qi. So in this expression, this I is ranging from 1 to n. Here it is written 1 to n. So these expressions are very much similar. Here Q net is equals to summation of I is equals to 1 to n Qi. So the additivity of charges means the algebraic sum of all the charges will be same as the total charge of any isolated system. So till now we had a discussion on the basics of charges, that is the definition of charge, and four very important properties of charges: electrostatic force, quantization, conservation and additivity of charges. And then in the next class, we will discuss about electric potential and potential difference. Thank you very much.